That's my water bottle.
What's up, Algebra 2 students? Let's do the homework. We are solving quadratic equations just like we did last unit. But instead of factoring, we're going to keep it a little bit, I think, easier, simpler. Instead of factoring and worrying about like the numbers and the X box and everything like this to get the answers 4 and -4. Now notice like the answers for this are going to be -4 and +4. -4 makes this 0, +4 makes this 0. Instead, different way to get these answers, we will isolate the square like we are solving an equation. We are like getting rid of the stuff that's bothering the square, isolate the square, and then we will square root to undo the square. The square root is the arch enemy of the square. They undo each other, they like fight to the death, and boom, they both die. Okay? So these go away. They're gone. And you just get x on this left side after you square root the square. Now, the square root of 16, you know what the square root of 16 is, but if you don't, we're checking with our calculator. If we get a whole number, we're done. If we don't get a whole number, we need to simplify. We get 4. So the square root of 16 is just 4. But here's just one little like heads up. If you use a square root to solve an equation, you need a plus or minus. That is how, using square roots, we get those same solutions, +4 and -4. If you use a square root to solve an equation, you need a plus or minus. That's it. Isolate the square, square root both sides, solve, and we're good. This guy here, isolate the square, I'm going to get rid of the 64. Adding the opposite. Square root both sides. The square root will undo the square. They die in a glorious battle. And the square root of 64 I can do in my calculator. If I get a whole number, I'm done. If I do not get a whole number, we're going to look to simplify. Okay, yeah, the square root of 64 is just 8. But remember, we have two solutions. We saw that with factoring. We have two solutions here. If you use a square root to solve an equation, you need to understand you could have two possible solutions. That's because both -8 times squared is +64. -64 is 0, solves the equation. And +8 squared is +64. It's the fact that squaring, you get negative and positive. When you square things, square negatives, you get positives. Square positives, you get positives. Two possibilities to get that +64 that we're looking for. Okay. Okay, 25x squared minus 1. If we were to solve an equation to just get this by itself, what do we do? Undo what's being done by adding the opposite. That comes first. That's the last thing being done. And then we will divide to get rid of the multiplication. We have isolated the square. We will now square root both sides. Don't like to square root everything. We just square root both sides. Okay? The square root and the square will undo each other. They are arch enemies. Boom, 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 boom. Just leaving me with x. But I do need to square root 1/25. Now, we talked about last class. If you're square rooting a fraction, you can square root the top and square root the bottom separately. Now, let's go to our calculator. The square root of 1, okay, that's just going to be 1. The square root of 25 is just going to be 5. If this was a decimal, I would need to simplify it, but it's not. I need a plus or minus because I'm using a square root to solve an equation. Okay, so I get positive and -1/5. Same thing here. Just like we're solving an equation, get rid of the stuff that's being added first before we get rid of the stuff being multiplied and divided. Getting x squared by itself. Isolate that x squared. We're solving for x squared. It's happened before. How do I... It was like a YouTube video. Sorry about this. I'd rather just figure this out before it's like the webcam's on, but oh, there it's back. Whoa. I feel like I broke the... It's back. Is it back? All right, cool. Sorry, rather have me up there. I am here. Get the x squared by itself. It's like we're solving an equation, only we have one extra tool now. To get rid of a square, we'll square root. They kill each other off. We have the square root of 1 over the square root of 9. Use our calculator. The square root of 1 is 1 again. The square root of 9 we know is 3. If I were to get a decimal when I did those square roots, I would need to simplify like we worked on last unit. Plus or minus 1/3. I'm going to stop listing them off as x equals negative and x equals positive. And I'm just going to keep it like this. Positive or negative 1/3. We have two answers, a positive and negative answer. Okay. All right. Add 324. Isolate this x squared like we're solving an equation. Divide by 4. Use our calculator to do that division. Boom. That's nice. 81. Square root both sides. Square root will undo the square. The square root of 81 is just 9. Square root both sides. Arch enemies. The square root of 81 is just 9. We're using a square root to solve an equation. We need a plus or minus. You're probably doing these a little bit quicker than I'm doing. Because it's like, yeah, okay, I got this. Like, no big deal. A little bit repetitive here. These are ones that we could have factored. We factored using like that m squared minus n squared, difference of squares rule. But we don't have to factor anymore. Maybe this is easier. Okay. Remember factoring? Let me just show you factored here. It's the whole m minus n, m plus n. As long as we know what squared gives 49x squared. 7x, 2. Remember doing that, factoring that? Well, we get, after solving these equations set equal to 0, the same answers. Add 2 divided by 7, 2/7. Subtract 2 divided by 7, negative 2/7. We're going to get the same answers, just a different way. Okay, so it's the same stuff that we've been doing. Difference of squares, only isolating square. But now we have vertex form. Okay, vertex form. Y equals a x minus h squared plus k. We haven't seen this since we've graphed quadratics. And we were told vertex is at hk. All right, remember that? So like that minus 1 means we actually shift to the right 1. It's opposite with the inside of the parentheses. The minus 4, we shift down. The vertex is at 1, negative 4. Okay, I'm going to show this on Desmos if it works. How that vertex is at negative 1, 4. But what we didn't ask you to do with vertex form is find the solutions. Okay, we want to take this equation and set it equal to 0. Now it's up to you whether you want to just change y and put that y equals 0. This is like when we were graphing to solve. Or if you're more comfortable with like this equation equal to 0 on the right side. It's up to you. But when y is 0, we will find our x-intercepts. Now, it's the same procedure, though it looks a little bit different. We want to isolate the square. Isolate the square. Add 4, right? Get rid of that minus 4. To isolate this square, Now, don't try to simplify the square. Don't try to like square the x and square the -1. It's not correct. You can't do that. X minus 1 squared is x minus 1 times x minus 1, which ends up being x squared minus x plus 1, which is x squared minus 2x plus 1. So like you could turn this into x squared minus 2x plus 1, but it doesn't help, okay? So I'm just like warning you guys, don't simplify, just get rid of the square. Square root both sides once you have the square isolated. Now watch how that's going to look like. The square and the parentheses are gone, leaving us with just x minus 1. The square root of 4. 2. Did we use a square root to solve an equation? Yes. So we need a plus or minus 2. Now, we still need x by itself. And a lot of people think, okay, add 1 to 2 and you get plus or minus 3. Wrong. Wrong, 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 wrong. Here's what I'm going to show you once, and then I'm going to just kind of give you a little different approach to do it. Let's pretend we are listing plus or minus 2 as two different numbers, where we have x minus 1 equals positive 2 and x minus 1 equals negative 2. Well, if I were to solve both of these equations, I realize I don't get plus or minus 3. What I get is positive 3, yes, but then adding 1 to negative 2 is negative 1. So x equals positive 3 and x equals negative 1. I don't want to use the parentheses because I don't want you to confuse this with a point. The point is the vertex. X equals are the x-intercepts. Now, that's one way to do it. Here's what I'm going to tell my students is don't add the 1 to the 2 because it's two different 2's. It's a positive 2 and a negative 2. Add the 1 in front of the 2. And then realize you have 1 plus or minus 2. 1 plus 2, 3. 1 minus 2, negative 1. So I'm going to write 1 plus or minus 2, then I'm going to do the work, and I'm going to write the x-intercepts. Okay? Let me show you maybe another example. First things first, where's the vertex? H, x minus h plus k. The vertex is as positive 3, negative 16. Oh, let me show you our handiwork there. I hope Desmos doesn't break the video. It's broken it before. Still alive. Watch this great stuff. Y equals x minus 1 squared minus 4. Vertex, 1, negative 4, x-intercepted 3, x-intercepted negative 1. It's beautiful. It's a beautiful thing, okay? Here, vertex 3, negative 16. X-intercepts. Set your equation equal to 0. Isolate the square. This is what we need to isolate this whole thing. Don't worry about getting the x by itself yet. We got to get rid of the square first. It's like order of operations. Get rid of the square first. How do I get rid of the square? Don't try to simplify it. Square root right here. This gets rid of the parentheses and the square, leaving me with just x minus 3. The square root of 16 is just 4. If this was a decimal, I would look to simplify it, which we'll see later. I get plus or minus 4. And ready? When you add 3 to both sides, don't add it to this 4. Okay? Because they're two different numbers. It's positive 4 and negative 4. If you do 3 plus 4, you get x equals 7. If you do 3 minus 4, you get x equals negative 1. Okay? Look at our handiwork. It's a beautiful thing. X minus 3 squared minus 16. There's my vertex at 3, negative 16. There's my x-intercept at negative 1 and 7. Okay? All right, I'm not going to show you anymore. We're just going to do the problems. Now, x minus h plus k. The A only affects opening up and being skinnier or wider, or opening down and being skinnier or wider. So I don't have to worry about that 2 when finding the vertex. I know the vertex is going to be at negative 2, negative 18. Okay? Now let's find the x-intercepts. This one is a little bit different because we have an A. Well, pretend it's like 2x minus 18 equals 0. What would you do first? You'd get rid of the 18 by adding, and then you'd get rid of the 2 by dividing. It's the same thing. We're just solving equations. We are just adding the opposite to eliminate the 18 from that side. We are then going to divide by 2 to eliminate the 2, right? I add 18 to both sides. I divide by 2. I'm now ready to eliminate the square to then solve for x inside the parentheses. Square root both sides. The square root and the square, arch enemies, they kill each other off. The parentheses are gone. You just have the x plus 2. The square root of 9. Well, we have to do the square root of 9. 3. Did we use a square root to solve an equation? Yes, plus or minus. What do I do to solve for x? I'm going to subtract 2. Now, subtracting 2 is like adding negative 2. I'm going to add negative 2 in front of the plus or minus 3. You can put it afterwards. It's fine. You're going to get the same answers, but I get x equals negative 2. Add and subtract 3 to it. Now we do the work. Negative 2 plus 3. Negative 2 minus 3. My solutions are 1 and negative 5. Okay? Look at this. X minus h plus k. So it's going to be skinny. It's going to open up because of the A. The vertex is going to be at negative 4, negative 4. That's nice. Let's find our x-intercepts. Take our equation, set it equal to 0. Okay. Pretend this is just like a big X, you know? What would you do? Get rid of the stuff adding and subtracting first. Get rid of the stuff multiplying, dividing second. Isolate this square. Square root both sides. That's going to undo that, giving us x plus 4. The square root of 1 doesn't undo anything. Like, you have to know what the square root of 1 is. This is a common mistake. People like think the square roots just go away. It goes away because it eliminates the square, but you are taking the square root of the right side. And you get 1. You used a square root to solve an equation. You need a plus or minus. Subtract 4 from both sides. I'm going to put it out in front. So I have negative 4 plus or minus 1. Negative 4 plus 1, negative 4 minus 1. Negative 3 and negative 5. Okay? Now, the next ones we're going to encounter, we're not going to be able to take the square root. It's not going to be nice. We are going to have ugly square roots where if I take the square root of the number, it's going to be an ugly decimal. We're going to go back to what we did day 1 to simplify. Okay? Let's see this. I don't like this example. I made it though, so we're going to have to do it. Okay, I got x minus 3 squared equals 2. I'm going to square root both sides. That goes away, leaving me with x minus 3. I need to take the square root of 2. Ugly. Now, we would try to simplify this if we could. Remember, to try to simplify things, we try to take out our biggest perfect square that goes into our number, but like no perfect square goes into 2. So we're kind of just stuck. So anyways, we're just going to leave root 2, but we have a plus or minus. But this is where like my kind of technique helps in the end, because like we can't simplify this. So we're just going to have to leave it, but we're going to add 3 to both sides so we can get x by itself. And the answer is 3 plus or minus root 2. Now, let's say on a quiz, they expect you to have a decimal answer. You would then type 3 plus root 2 in and 3 minus root 2 in. Again, if this was the square root of any other number, try to simplify it, okay? Now, I get 4.414 and 1.585. Now, the beautiful thing about this is like Desmos approximates that 0. You just found an actual location of the 0. Like, this is called an exact number, this 3 plus root 2. It's not a guess. It's the correct answer. Desmos is like, yo, 4.414, 1.586. Yes, correct, 4.414, 1.586. But you're better. You're better than Desmos because you have more decimal places. You know the actual answer, the exact answer is 3 plus this crazy decimal square root 2. 3 minus the crazy decimal square root 2. So this is where like human beings beat out calculators who just like approximate. Okay, let's look at this guy. What do we got going on here? This plus 54, let's get rid of that. Yo, how'd you get to the annex so quickly? Divide by 3, negative 3. Okay, before we do anything, negative 54 divided by negative 3. 18, okay, 18. We are ready to square root both sides. Gets rid of the square, gets rid of the parentheses, leaving us with just x minus 1. I tried to do the square root of 18. Bad. I then tried to pull out the biggest perfect square, like 16, like 9, like 4, or 1, if that's the only thing you can do. 18 divided by 16, yeah, that's not going to work. 18 divided by 9. 9 times 2 is 18. Root 9 times root 2 is 18. 3 root 2 is root 18. We used a square root to solve an equation. We need a plus or minus. We finish things off by adding 1 to both sides. Guys, our x-intercepts are at 1 plus or minus 3 root 2. Now, you know what's really fun about these answers right here? Like, let's go back to this 3 plus or minus root 2. And we're going to see this when we do the quadratic formula. Where's our vertex? It's at 3, right? So look at this. The vertex is the smack dab in the middle of your quadratic, right? Well, if you add a distance and you subtract the same distance, you're going to get points on your quadratic so far as you like go away from 3. So like we are saying start at 3, add this 2 root 2, or add this root 2. You'll get 1. Start at 3, subtract root 2. So it's like vertex plus or minus a distance. You'll see that next class when we end up doing the quadratic formula. It's the same thing here. We're okay if you list your solutions off like this. You might be asked to put both of the solutions down like that. So it's called like complex form, and we are okay with it. All right, last two. I'm going to add 75. Ooh, good one. Going to isolate the square, divide by 3. 75 divided by 3 is 25. Square root both sides. Now, what's going to be different about this? I'll show you. Square root of 25 is 5. Yo, add 3. Okay, add 3. Divide by 2. Divide everything by 2. Now, that gives me 2 options. I could leave my answer like this. We're going to see answers like this next class all the time. This is like a quadratic formula. Quadratic formula is just a formula that uses square roots to solve any quadratic equation. Or you could divide both of these by 2 to give you 3 halves plus or minus 5 halves, which is actually what I like to do because I think it's easier to do, but it's okay. Like 3 plus 5 over 2. 3 plus 5 over 2 is 8 over 2, which is 4. 3 minus 5 over 2. 3 minus 5 is negative 2. Negative 2 over 2 is negative 1. Or 3 halves plus 5 halves. You can do it in your calculator. 3 halves plus 5 halves, either using the fraction button or this. 4. 3 halves minus 5 halves. Negative 1. But again, it's like vertex plus or minus distance to solutions. That was a good one. Let's subtract 60. Let's divide by negative 3. Isolate the square. Square root both sides. Arch enemies fight to the death. They undo each other. They're gone. The square root of 20. Ugly. Try to simplify it. Divide it by 16. No, we know that's not going to work. Divide it by 9. We know that's not going to work. Maybe you don't. That's okay. That's why we're checking. Divide it by 4. Oh, this square root fits nicely into 20. 4 times 5 is 20, so that means root 4, root 5 is 20. That means 2 root 5 is root 20. Remember how we checked this? Root 20 is 2 root 5. All right, cool. But then we finish off by adding 1 to both sides. Oh, what did I forget? Plus or minus. Now, again, we can't add 1 to 2 root 5. We can't add 1 to this number. We have to do it separately. And it turns out like you can't simplify this at all. 1 can't be added to 2, and it's not 3 root 5. This is a common mistake. It's not correct. Ways to check, like 1 plus 2 root 5 is not 3 root 5. So 3 root 5 is wrong. Your answer is just 1 plus 2 root 5. It's going to be like tricky for a lot of you to like be okay with putting down. But it's right. And then 1 minus 2 root 5. We could graph, we could see that. We could see the vertex is going to be at 160. It's going to open downward. The vertex is at 1. We add and subtract this distance. We'll see that with the quadratic formula. So hopefully you understood this. Isolate the square. Square root both sides. You need a plus or minus. Because you have a plus or minus, when you then solve for x, because the square is gone, just make sure you're careful about how you do that. Okay? Hopefully we understand everything. Mr. Messner out.